Ladies and gentlemen, I am here as the leader of this epoxy project under Professor Jin Hong. It's a great pleasure to introduce our study to you today on the electrical nanocomposite of epoxy. So our study will deal with the three main considerations from verification of specimens and also analysis of results, which consist of scanning, electron microscope, X-ray diffraction, and the electric breakdown strength, volume characteristics. Lastly, I'll close this by the conclusion of our study. So now, I'll introduce our member with Anna.
Hi, my name is Kwix I major in electrical engineering. For nanocomposite, I have performance that is probability and verification of spatial.
Hi, my name is Kwix. I have conducted nano-composite epoxy in KWIX. I am in charge of the electronic breakdown and scan electron microscope.
Let me start off by briefing you on the research purpose. Nanocomposite and magnesium oxide can be given expected effect as below. Firstly, thermal durability is enhanced thanks to contribution of added magnesium oxide, keeping excellent property for insulation at a high temperature, and is environment friendly because oil such as silicon oil and gas like SF6 insulating material at a high temperature can be applied. Also, inserting durability can be enhanced, so it is possible to reduce the amount of raw material and make light and small materials toward the reduction of the volume of molding components. Let's turn to manufacturing specimens. Here is specimens of our study. It was produced using piston type Y8128 epoxy resin. Also, we will prepared liquid specimens consist of an high drive system and a 2200 hardening agent added MgO with 50 nanometer of average particle size. After stirring the hardening agent mixed, prepare the hardening agent and epoxy were mixed according to the weight ratio mixed in the ultrasonic wave for an hour. Then, remove the bubble by glass navigator. And after first hardening at 120 degrees Celsius for 2 hours, and again, second hardening process at 130 degrees Celsius for 8 hours. Then, finally, specimen for the electric breakdown was produced. Now, post hardening process is done at 120 degrees Celsius for 2 hours. Second hardening process is done at 130 degrees Celsius for 8 hours.
Completed one specimen. Thank you.
This video like the conclusion of our study. So as a result of cross-section of specimen, it was examined that Finland dispersed without concentration and 5.08% of specimen had excellent dispersibility. From XRD, the characteristic of each specimen showed slight peaks because of contribution of typical armor pulse high population between 14 to 25 degrees. So I'll show the electric breakdown strength like this. It has examined that in case of virgin, the electric breakdown strength decreased sharply at a high temperature, rising over 80 degrees Celsius. But the electric breakdown strength of MgO nanocomposite decreased gradually at a high temperature, rising over 80 degrees Celsius, thanks to contribution of filler. And lastly, I'll show the conclusion of volume relativities. Do you see that? As a result of measuring volume relativity at a high temperature region of 80 degrees Celsius, volume relativity of specimen 83.08% was more stable than that of other specimens. Provides information about the packaging materials of power semiconductor and the large electric power transfer equipment to small electric machine for changing properties used at a high temperature. Thanks to development of nanocomposite having excellent thermal properties. So study will contribute to development of materials for green energy and environment-friendly materials. Thanks for your attention, gentlemen.